Hi guys, today I want to talk about sustainable designs and SolidWorks sustainability module. So as many of you may already know, sustainable designs means designs that cause least damage to environment. This is the trend now, right? We want to people are more environmental conscious, the even in the design, people are thinking about how can we design products that are good for the environment, that don't cause any damage to the environment. uh, in other important or other familiar term for a sustainable design is green design, right? We want to design green products. So the question is, how do we know uh, how green our design is or how sustainable our design is from the environmental point of view? So to analyze our design from environmental concerns point of view, we can first generate the design, we can create the CAD model, and then we can run SolidWorks sustainability module, and that will check our design from various point of views. So there are various metrics that have been developed uh, by people to analyze the design from sustainability point of view. So one of them is carbon footprint. This is basically the the carbon dioxide equivalents, kilograms of carbon dioxide equivalents generated by your design during its entire life cycle, during right from the material extraction to the manufacturing of the design to transportation of the product to the final user, the use of the product, and finally expiring product or recycling it. The so during the entire life cycle of this product, how much carbon dioxide equivalents were produced can be measured as carbon footprint. And that's just one of the metrics. There are many other metrics such as energy consumption is also very important. Particularly, we are talking about non-renewable energy consumptions, the bad energy, not the good energy, the renewable energy. So that can be calculated for your product, and we are talking about the entire life cycle of the product, right? Air acidification, water eutrophication, and I'm not going to talk too much about these. You can explore them on internet, you can learn more about them, but these are just a bunch of metrics that SolidWorks can calculate for any design, and based on these metrics then you can basically assess your design from sustainability point of view. So how the process works is, first you complete your CAD model, then you provide certain inputs in the sustainability module, such as what materials you are using, what is the manufacturing process, uh, where you are manufacturing your product, manufacturing region. Because why that is important, because then that will determine the transportation of that product from the manufacturing region to the where actually the customers are. So transportation and use. And SolidWorks has library of these inputs, like different types of materials, manufacturing processes. It has a library of uh, massive library of all this data that you can pick and choose from. And then you not only analyze your design, but uh, you can change the things, right? You can change material, you can change the manufacturing process, you can change where you are manufacturing. And by playing with these things, by changing your inputs, you can basically optimize, you can come up with the different methodologies or different processes through which you can optimize the design sustainability of your design. So without further ado, let's get started. We are going to make this simple steel washer and then run the sustainability module to see how it works. So I'm going to click start a new part. The dimensions are in inches, so that's good. I can keep it the units as they are. Then okay, and let's see. The dimensions should be here. We have a diameter of inside circle is half an inch and outside circle is 1 inch. So let's do that. So I'm going to select the top plane and extruded boss. Then I'm going to draw two circles. Inside circle is half an inch. So smart dimension, diameter of the inside circle is half an inch. Diameter of outside circle is 1 inch. So that's your basic sketch. The sketch is complete, so you can exit the sketch. And thickness is 0.125. So let's change that. 0.125. Okay, so that's your simple washer design. I'm going to save this file, save as, select temporary files, and I can call it part one, or I can give whatever name I want to give it to it. So that's that. We got the part complete. I'm going to put it in isometric orientation. The next thing is to access the sustainability module. So in this version of SolidWorks, which is a SolidWorks Premium 2020, uh, I click on Tools, and I have something called as SolidWorks Applications and Sustainability. So uh, depending on which version of SolidWorks you are using, it may be little different. For example, you may want to check, like suppose you don't find this particular pathway, then you may want to look into a couple of things. First of all, on the tools itself, on this panel here, check if you have a sustainability or sustainability express available. If not, maybe you want to check in the express products, see if that is there. But hopefully, most likely, it's you're gonna have a SolidWorks applications option there, and within that you have this sustainability module. So I'm going to click on that. Okay, so here we are. It shows you basically the entire life cycle of the product, right from the raw material extraction, material processing, part manufacturing, part assembly, product use, and end of life. And during each of these phase, the transportation that goes between these phases, that is included, right? So I'm gonna say continue. Okay, and now we can define our inputs. So first, the material, right? For the material, you can choose. For now, we can choose steel, and in steel there are lots of different steel alloys, like you can see here. But I'm going to keep it default 1023 carbon steel sheet. So that looks good. Then I'm going to scroll down and look at this manufacturing. So we will keep Asia as the manufacturing region. We're going to manufacture it in Asia. Then scroll down, manufacturing process. I will change it to stamped. This is the stamped washer, right? So I'm going to change it to stamped or formed sheet metal. Okay, so I changed the manufacturing process, and you can already see carbon footprint, energy consumption, air acidification, and water eutrophication. These four outputs or four metrics, their values are showing up here. Uh, Now I'm going to scroll down here, and use is North America. So I will keep that as that. So here we have given the inputs regarding the material, manufacturing process, manufacturing region, and the use region. And then SolidWorks does the calculations and provides us these inputs here, right? Uh, Now there is some baseline that SolidWorks is comparing this with, and depending on that baseline, we are seeing how much reduction in air acidification. For example, previous baseline, whatever that was, right? As compared to that, uh, we can have 35% reduction in air acidification, and so on and so forth. So next, what I'm going to do is, this is our first trial, right? This is first trial just to analyze the current design and set inputs. Now that we know this, we can set this as our new baseline. So at the bottom here, we have this option here, set baseline option. There you can click on that. So that becomes the new baseline, right? That gives us opportunity to change a few things and hopefully try to reduce carbon footprint, air acidification, energy consumption, and water eutrophication values. Okay, so with that, what we can do is we can go back now, change some inputs, right? We want to optimize this design from the sustainability point of view. So what will happen if instead of steel, I use aluminum alloys? So I'm selecting aluminum alloys, uh, and subclass, we can choose from there alumina. So let's see, here is alumina. Okay, rest other things, for example, the we will keep the same manufacturing region and same manufacturing process, which is stamped and formed sheet metal. uh, and of course your final use region is not going to change, it's going to be North America. And now you can see here, by changing the material from steel to aluminum, you can have 57% reduction in carbon footprint, 61% reduction in energy consumption. I guess air acidification doesn't change much, that value, and water eutrophication minus 54%, right? So that's good. We can do one more try. This in this case, instead of doing aluminum, we can change the material, and let's try to change from aluminum alloys to plastics. How about that? Plastics. We can, of course, if you want aluminum to be your new baseline, that you can do first. So if you want to do that, then you can set this as your new baseline. I'm gonna do that. S- this- Okay, and now we are going to use plastics, and there are different types of plastics. We will choose epoxy unfilled. Epoxy unfilled. Let's see, right here, epoxy unfilled. Again, you need to have knowledge about materials to understand all this, right? Uh, and other steps like manufacturing, uh, and of course now it is plastic, so it cannot be, the manufacturing process cannot be stamped, uh, because plastic parts are made by injection molding process, right? So it's automatically changed here, injection molding. Region is Asia where you are manufacturing, and use is North America, so I can change that. And looks like by going from aluminum to plastic, we are actually making it worst. So we really don't want to do that, right? So that's how it works. This is how it works. You could do trial and error. You can change things here and try to optimize your design. When you are done, now you want to publish a report. Then you can come down here, and there is an option called as save as. So I might want to click on save as, and there's a report here in the docs format. I can save it in this same folder, temporary files. Okay, but since I don't have Microsoft Word installed on this computer, it's not gonna be printed. Microsoft Word is required to be installed on machine for generation of report, right? So I don't have that, so it's not gonna be printed. But if you have a Word, Microsoft Word installed on your computer, you should be able to generate the report without any problem. But what I did here, just to show you, I have a report already that I will show you. So this is how the report looks like. You can add some information here, your company logo and things like that. But SolidWorks sustainability report, you can see here the CAD design, basic CAD design that we made. The last material epoxy and field, right? It gives you the volume, surface area, all the mechanical properties, manufacturing method, injection molded. Uh, Here the it talks about your manufacturing region, use region, and here are uh, the metrics and their values. and you can see carbon footprint is and it also the total carbon footprint, which is 0.01 kilogram per carbon dioxide kilogram carbon dioxide equivalent. It also divides that with a pie chart format here. How much of that is in which phase? So material phase is the material itself is responsible for a big chunk of that carbon footprint, right? Then the manufacturing, then use is not much, but the end of life recycle also another good chunk. So and same in each category, right? So we have these values that we can look at, and to me it seems like the choice of the material, the selection of the material is key, because it's the blue in every pie chart. The material has the biggest impact on the matrix. So that is that. Then you have the baseline carbon steel sheet. uh, it's that is that you have there, right? uh, some environmental impact comparison, whether your original design was better or the new inputs are better, the better worse, so it gives you in each category, right? So that's, and then that is it. And finally you will see there is a glossary of terms. For example, water eutrophication, right? What is the definition of water eutrophication? What is the definition of total energy the metric that we are using, they are precisely defined in the glossary in your report. And this is as SolidWorks in collaboration with the Gabi software. This sustainability module works. So that's all this is. Hopefully now you can run sustainability module for all kinds of designs that you will make in future, and ensure that you are designing responsible green products. So with that I will stop here. Thank you.